afternoon, everyone. Thanks again for joining. And I think we're probably almost we've got a great number of attendees today, so I think I'll probably begin and make some introductions, if I may. My name is Joe Huddleston. I'm from the British Council for Office's NextGen committee, so I'm the chair of the committee. So very good afternoon to everyone who has joined us today for the webinar. The British Council for Office's Midlands Committee's presentation and discussion around the Beginner's Guide to Smart Buildings. So this is some research compiled by Arup, and today is presented by Richard Pearce, who joins me. So a big thank you to Richard Pearce for spending the time to talk through this. So I'll gladly introduce Richard in just a moment. If I may, just prior to this, I'd like to thank D-Line for supporting today's webinar. The support we get from our sponsors is really a huge help in allowing us to host such events and such initiatives. So thanks to D-Line. Further to this, we've got a host of planned events coming up, so we'd encourage you to take a look on the BCO events page for further information. Just a few coming up on the 14th of July. We've got a virtual tour of Unity Campus in South Cambridge. On the 16th of July, Psychology of Work Life during and post-COVID, and the 23rd of July, Flexible Working in a post-pandemic world. So I know they're topics that we're all wanting to know a few more answers on. So their webinars 14th, 16th and 23rd, but please do have a look on the BCO events page. So if I can introduce Richard, and then we'll get things kicked off. So Richard Pearce is an Associate Director at Arup, and is the Electrical Skills Leader for the UK, India, Middle East and Africa. I think there's a 370 strong team across the regions, and Richard's experience spans over 2 decades. He's worked on many of the commercial buildings in the Midlands, so the schemes that we probably all know very well, including the Snow Hill Estate, Paradise Circus, to mention just a couple of those. And in recent years, he's also been heavily involved with the adoption of BIM into Arup's business as normal operations, and since then he's led a group digital transformation. He's been looking specifically at the opportunities that this brings for Arup and its clients, and I wonder if we'll probably touch on a few of those points in today's webinar. So in terms of a presentation and a setup, can I suggest that any questions, if you send them through on the Q&A, and I'll take a log of them, and then we'll cover the Q&A at the end if that works for everyone. So I'll read out some of the questions if we get those during. Propose we present around 40 minutes, depending on how Richard's feeling about that. But that'd be great. So I think that's it really. Over to Richard, but huge thanks everyone for joining today. It's good to see great numbers, and as a webinar, it means we haven't got all wet and soggy here heading outside. So thanks everyone. Send the questions through, and look forward to hearing Richard's presentation and the comments later on. Thank you. Over to you, Richard.
Thanks very much, Joe. Thank you for the introduction. That's very kind of you. So yes, welcome everybody. Good afternoon. The presentation today is all about smart buildings, and it's a fairly new technology, I think, to a lot of people. So hopefully some of what I've got to share with you today is of interest, and as Joe said, any questions please raise them on the Q&A section, and we'll come back to them at the end of the presentation if that's okay. So I'm looking to cover today a few different topics, but effectively the overall topic is about getting people's mindsets changed, really, about how buildings might be delivered in the future, and how you might to sort of operate with a building and integrate and coordinate with all the systems that are within the building. People are probably a bit more familiar with some of the technology that is now coming into their homes, things like Google Nest for controlling your temperatures and Philips Hue for the lighting. And effectively what we're talking about is how we can use that type of technology effectively, or commercial versions of that technology, in commercial buildings. So I'm going to start off by explaining what we think at Arup a smart building is, and I'll come on to why I say what we think, because I don't think there's one single definition. Then I'm going to touch on how the user experience and technology need to work together to really get the best out of a smart building. What you then need to do to look at enabling a smart building, so that goes into a little bit of technical detail, but nothing too heavy. Then how we need to think about such technology and how the various sort of design stages need to adapt to be able to bring in and integrate what you need to do to consider a smart building. And then finally, I'm going to touch on how it's important to really visualize the data. And that might be smart building data, but I'll touch on a couple of examples that hopefully will bring some good understanding to that. Okay, so let's start with what is a smart building? The reason I start with this is that I did do some research into this, and I don't think there's a single definition of what a smart building is. So it could be, some people's definition could be all about automation. So it could be a commercial building with automated systems, like automated lighting. You know, you walk into the space and the lights come on absolutely fine. Some people might consider that to be smart. Personally, I don't, and I'll come on to why that is in a second, but I think it could then be an evolution of that. So it could be smart sensors that are deployed throughout a building to allow the operator to get more information out of a building. And again, that is a reasonable definition, but I think what's really important is that we focus on the human-centered approach to installing technology into buildings to really make sure that we're improving the experience of all users, not necessarily the facilities managers, and not necessarily just looking at automation of a single system, but bringing all of these single systems together so that they can work together and provide a much better experience for the end user. So just to try and make that slightly clearer, like I said, if you walked onto a floor plate and the office lighting turns on automatically, that's been around for years. That's a simple sensor that integrates with the lighting control system and operates the lighting control system for you. To my mind, that's automated and not smart. But if you walked into a building and you swiped your access control card at the barrier, and the barrier then effectively said, "Oh, hi there, Richard, you know, you're first of your organization to enter the building today, so I'm going to turn the lighting on in the floor that you normally work in." That to me is a better user experience. That's saving energy and also looking at two systems working together to get the best out of both systems. So that to me is a good example of smart technology. And then I'm just going to touch on this. This is a really interesting graph, and some people may have seen these before. These are called hype cycles. They're produced by Gartner. They do produce a number of these different ones, and they're a really good sort of source of information in terms of where research is. And if I just explain the graph for a start, and then I'll come on to why it's important, I think, for smart buildings. So you'll see at the bottom left-hand corner, effectively what we're talking about here is what's called an innovation trigger. So that might be a bit of research, or it might be somebody like Elon Musk doing something completely different, you know, very off the wall, creating a new technology to talk about. Then we have the peak of inflated expectations, so this part of the graph effectively. And what we're talking about there is effectively where all that hype has gathered momentum and everybody is talking about these technologies, but not necessarily delivering the technology. So it's all about those expectations, at which point then people start to get a bit of a reality check and they drop down the curve to the trough of disillusionment when they realize that perhaps things weren't quite as they were originally sold. And then once you've got past this point, you start to realize, no, actually, there are some really useful benefits to this technology. And you start to understand what those benefits are. So you're on the slope of enlightenment before you get to the plateau of productivity. So I really like these curves because I think it's a really good and actually a really practical way of looking at new technology. And just looking at augmented reality, some of you may remember quite a few years ago, sort of images of people in almost boxing ring type environments with virtual reality type headsets on. And then they evolved into things like Google glasses, and Google then started to overlay information onto those glasses. So it became augmented reality. And then Google stopped doing the Google glasses and it all went quiet again for a bit. So that's quite a good explanation of, you know, Google on the hype curve would have been here a few years ago. Then they withdrew the technology for a bit, and so it's dropped down here in the trough of disillusionment. But now what we're actually starting to see is some really good practical examples of augmented reality. So again, it could be a Google Glasses type technology, but there are some technology companies that are starting to overlay, say, maintenance information on those glasses, on the augmented reality. So a maintenance technician could go up to a piece of equipment and seeing the augmented reality, seeing their vision, effectively, the instructions for how to maintain that piece of equipment. That is a really good practical application for augmented reality. So we're here, we're on the slope of enlightenment effectively now with augmented reality technology. You'll see this is a couple of years old. So I do genuinely believe that these graphs are actually quite realistic. And why it's important for smart building is you'll see that a lot of the technologies we're talking about are quite high on the peak of inflated expectations. So for me, that means that we have to take a little bit of caution in terms of what we're doing in building design and how we incorporate them in building design. Because if we're saying that, oh, everybody's talking about smart buildings and smart technologies and IoT, that's fantastic, but we've still got to get through this trough of disillusionment when everybody realizes they're not necessarily quite getting what they originally were sold for. So the solution that we're proposing, and the one that we're effectively pushing for, is we think you need to enable buildings now so that you can accept this technology, you can accept smart workspaces and smart building technology into your designs today, but don't go over the top. Don't try and solve every solution now, because you'll probably find a little bit of abortive cost if you do that. If you enable your building so that it's effectively able to take on smart technologies later, then you should be minimizing your abortive cost. And actually you can focus on what's really important today and then come back in a couple of years' time and maybe add something else on and something else on. So as you go through that trough of illusionment. So hopefully that's clear, but I think that's quite important because effectively it sets the benchmark for why we're proposing an enablement solution, not necessarily trying to answer everything in one go. So this is the concept that I'd like to talk about, and this is about fundamentally providing a future-proofed solution that is vendor agnostic and can be scalable, really, and it's quite a straightforward solution, really. So these are the systems that you'll find in your building. It could be a lighting control system, could be the lifts, could be the BMS. These are the apps that as a user you would interact with, so that an app perhaps from an estate, if you were in a building that's owned by somebody else, then this would be an app that perhaps they provide access for you to use. And the idea is that we need to create this cloud platform in the middle. And what the cloud platform does is take information from the systems, from each of the systems in the building, populates the cloud platform with data, and then allows the app to access that data. So any one app can access the information, and the app could potentially change that information and push it down into one of the building systems, or the app could integrate the data and interact with another app, or one system could interact with another system. So it's quite a straightforward concept, but this middle layer effectively is what's key, in our opinion, to really getting the best out of a smart building solution. And once you've done that then should help you to realize the most benefits from your building services and the systems that effectively are in there. So it might be that you start to take some information from sensors. So it could be real-time sensor information. It might be external sensors that would be traditionally seen on a building, so weather sensors. Or it could be that you start to include more occupancy sensors, for example. So you've got a much clearer understanding of how your building is being used at any one time. And these could be IoT sensors. To me, an IoT sensor is still a sensor. It's just communicating in a slightly different way. So I wouldn't get too hung up about the term IoT in some ways at the moment. It's still a sensor fundamentally. But once we've got that type of information, you can then start to look at the data that you're gathering from that information and start to use it for predictive analysis. So using machine learning and artificial intelligence, you can start to get more and more insights out of that data. So if I go back to my occupancy example, today, without sensors, most building occupiers will have a bit of an understanding of how their building is occupied. So they may know that most people arrive at the building at, say, 8:30. By 10 o'clock, most people are there. They take their lunch break at, say, between 12 and 1 or something along those lines. And they can use that information to provide the right services. But what they might not be able to sort of understand in so much detail is how that might change throughout the week and the finer details of that information and how it then changes month by month and year by year. So if I was to consider perhaps a large estate, of a number of buildings. And actually, rather than thinking of commercial buildings, higher education or a healthcare environment might be an easier one to visualize at the moment. So if you've got a higher education estate and you've got, say, 5 or 6 buildings, wouldn't it be useful to know when your occupation levels start to fall to the point where you could shut one of those buildings down? You know, that means that you can start to save energy in that building far more than you would ever have been able to do before. And actually, through the predictive modeling and machine learning and artificial intelligence, that is entirely possible. So your occupancy data can start to populate a database, and the machine will start to say, well, actually, next week, I'm expecting that you will get below a threshold by Thursday. So perhaps on Friday, you could divert all of your courses to a different building and shut that one down. Or perhaps that's the day that you do more maintenance on that building. So that's what I mean by machine learning and artificial intelligence. It's effectively using the data to provide you more insight so you can better manage your estate and your building in the future. And that data is fantastic, but that's where we come onto this box here. It's only as good as the way that you visualize it. And I've got a section on that at the end of the presentation because I think it's really, really important. All of that data that I talked about could be displayed in a spreadsheet. And that might be okay for me as an engineer. I might be able to analyze that spreadsheet and get the information out of it that I need to make those decisions. But not everybody's an engineer, and a lot of people struggle with concepts of 3D and visualizing spaces and so on. So what we really need to think about is how we can use that data and visualize it in the right way. And that's where the BIM comes into it, or reality capture of your existing building comes into it, so that you can really start to apply data onto different visual techniques so that you can get the most out of that data. Okay, these are just a snapshot, really. They are our clients, but I think it does give you a view of the type of clients that are looking at this type of technology here today. You know, it's not just the big technology companies like Google. We've got people, you know, Lush Spa, for example. I wouldn't have expected them to be considering this at the moment, but you've got other people like museums, and you've got companies that are effectively building speculative office developments, looking at how it can provide facilities for their tenants. So it really is crossing a number of different sectors, even within purely the office environment. So I think it is a really important technology to look at in more detail. Okay, so that's the very basic introduction to what smart buildings are about. And now I'm going to touch on the next aspect, which I think is super important. So this is all about user experience and how the user experience and technology must be considered together to get the most out of your smart building functionality. And my best example of this, I think, really is if you think about your phone, your smartphone. When smartphones first came along, I think there was a bit of doubt. People tried to, you know, why on earth do we need all of a sudden a smartphone, a phone with a huge screen? What's it going to do? How's it going to change my life? Now, me included, you can't live without your smartphone. You do everything on your smartphone. You know, you book your hotels on it. You're constantly on it with emails or Facebook or whatever it might be for. And I think the point about that is Apple and other manufacturers that have really invested in smartphones came up with a solution that was able to accept ideas later on. So all the apps, all the good stuff that you use every day, they didn't exist at the point that the phone was created. Some of them were, and some of them were migrated across straight away. But the thousands of apps that you now can get for your smartphone, very, very few of those really in proportion existed. So if we think about that in a building term, what we need to do is we need to provide a system that allows that same sort of evolution of technology. Let's enable the building to accept smart technology so that in the future we can create the apps that we want and apply that to that technology when those apps are available or when the idea is generated. We don't want to constrain ourselves too much. So this slide really covers 3 primary purposes that have got to come together to really make the smart building successful. So you've got to get the connectivity right between various different systems that are within a building. And that might be sort of energy monitoring systems or controls. But you've also got to get information. So you've got to get insight of the right information to be able to integrate with those systems. So like I said about how many people you might have in a building. And fundamentally, more than anything, that technology, that convergence of the building technology and the system information has got to come together to really enhance the building for the people that occupy it, because what's the point if you don't enhance the user experience? So all those 3 aspects are all as important as each other. So we want to focus on that user experience design. We want to make sure that we're getting the user experience right. And I just wanted to pick up on a few terms that you might hear when people talk about user experience and user-centered design. And that's the user experience is effectively the outcome that's experienced by the user. So, you know, how you actually experience something, how you actually interact with your phone. The user-centered design is what we as designers really need to think about. So we want to use user-centered design to get the best user experience, really. And I'll come on to how we're doing that shortly. And then the user interface is what you physically interact with. So it's usually a digital interface. It could be your iPhone or your Android phone. It could be a touch panel outside a meeting room. It could be a piece of signage that changes as you walk past to tell you something different. So, you know, three aspects there of sort of the overall user experience design that's important to understand. And if we get all of this right, the boxes at the bottom then should really be realized. So we should be able to produce buildings that have less complaints because the building owners and operators know about the problems as quickly as the people that are within the building. So that's a great win. You know, if there's something not operating correctly, actually being quite proactive and saying, I'm really sorry, but that's not working today, is far better than 10 or 15 people coming to you saying, this isn't working. Got to be a better solution. It can de-risk the design process because effectively we can focus on what's important to those users. So we can try and make sure that the solutions that we're delivering really answer what the users are asking for. So that's really important. We can make the buildings, the way that you interact with the buildings far better. So if we look at the way that people move through a building, we can focus the right technology and the right information in the right places. Let's not just think that a light switch needs to be there for the sake of it. Let's work out where the right place is for that light switch, much more important. We can make these buildings far more desirable. If we know more about the buildings and we know more about the environmental conditions within the building, then actually that becomes a bit of a selling point, doesn't it, really? So we look at BREEAM and the WELL standards and they're fantastic, but it's all about design. You know, let's start to look at how things are actually working in the real world. What advantages is this building over another one? We can really rethink design. So I've got some great ideas about that in terms of how you interact with a building, what that process might be as you walk through that building. But to me, that's probably one of the hardest things to think about. How would you like to interact with a building? What experience would you like when you walk through the front door? Do you want somebody to know who you are instantly? Would you be like to be welcomed like you are in a Starbucks with your name or your fake name, whatever you prefer? You know, how do you want to react with your building? So that's good. And the narrative is really important because as designers, we will spend a lot of time, you know, we might spend a couple of years on a large development, really fine tuning the user experience and really understanding what we believe is required. But we've got to make sure that that narrative is then explained to the people that are actually using that building. So there's no good as creating the most technologically advanced building if we don't explain to people how it works and how they interact with it and how they use it. So that user experience piece is super important. So let's start with the user experience when we look at designing buildings. And this is, to me, where I think architects, as engineers, we can learn an awful lot from architects because this is effectively how an architect would look at it. You know, go and meet the client, go and understand who the stakeholders are and try and get to the bottom of what that user experience is. We need to understand the what, the why, and the how. So let's understand the user needs. Let's understand what type of spaces are required. And let's understand how they want to interact with that building. You know, that's really important as an engineer now, just as much as an architect. And the way that we're approaching this, so this is the way that Arup are approaching this, is using this double diamond process. And I want to spend a little bit of time just explaining what this is. So effectively, if you start on the left-hand side of the slide, we need to discover what the problem is that we're trying to solve as engineers and architects and designers. And we're starting with nothing, really. We don't know what it is. So we'll walk through the door to a client, and at the point we're walking through the door, we'll have very little information. So what we've got to do is an awful lot of research to get to understand what the problem is that we're trying to solve. And that's why we're effectively expanding the diamond here. We're expanding the triangle to the top of the diamond. So we now get to this point and we've got an awful lot of information, possibly too much. So we need to try and actually refine that information down to define what the actual problem is. What's the vision that we're trying to get to? So effectively that's coming back down the slope in the research slide. And then you get to this point here And we then have a vision. We understand what it is that the client wants. We understand how people want to interact with the building, but only at a very high level. And that's where the design starts to come in. So the design is then saying, okay, I understand what your vision is. As a designer now, I need to develop some solutions and put those solutions to you. So we're going to start developing again and increasing the number of solutions that we've got, and we get to another peak. And then we need to go back to the client and say, so these are all the options. What is it you actually want delivered? Because no client can afford every single solution that you come up with. It's just not practical. So we then work again with the client again to find out what it's really important to deliver. And then you come down to the end of this diamond here. So hopefully that makes sense. But just to put it in context, the research piece is all about stakeholder and user workshops. Very, very traditional process really in designing buildings. So that's fantastic. But what we'd like to introduce more of is personas. And by that, I mean that's thinking more about the people that are using the building and how they're going to interact with the building. So again, focusing on that user experience. When we're looking at discovering the problem, you could do that in all manner of ways. So at the moment, you know, perhaps a survey actually is perhaps one of the best ways of doing it. Really think about what information you need to get out of that client to understand how they want to interact with their building in the future and what sort of technology might be appropriate. So some typical questions here about, you know, what sort of level of access control and is important to you, and then visualize that really, really clearly. This is all about making sure that the experience is good, not just from a building perspective, but from a design perspective. So it's quite obvious from here that the more orange is more important to this particular client. So try and put the information across as clearly as you can, and that's what we're trying to do today. So really taking engineering a good step forward from that perspective. These are personas, and I just wanted to touch on this because I think it's quite a really interesting way of looking at how to design a building. So we've got to think about who's using this building, but not necessarily just on a day-to-day basis. This person here, called Superlocal, could be a visitor. So we're looking at a visitor that actually lives quite local to this site, and that person is going to interact with the building in a slightly different way than perhaps a VIP visitor might do, or somebody that's traveling a long distance, because this person might arrive to the building on their bike. So they need to understand where to get their bike. Where's the bike shelter? Are there any showers? That type of question. Well, if we look at a VIP, the client probably wants to make the VIP's experience as seamless as possible, with as least security as possible, while still maintaining, you know, an appropriate level of security. But if we look at a visitor that's coming further afield, they're probably going to come in the car at the moment, particularly at the moment. Where are they going to park? Can they park on site? Do they need to be told a particular parking space? So by looking at sort of those personas in a lot more detail than perhaps we have in the past, then we can really refine our designs and really look at what that user journey is like. So that then gives us a vision. We come to the end of the research piece and you've got a vision, and it might be that you've got a number of case studies that are shown. It might be about, you know, sort of well-being type things that might be important. It might be security, as I've said. It might be the provision of services. It might be, I really want to make sure that, you know, the coffee facilities are as good as they possibly could be and as accessible to everybody as they could be. So we've got that vision. We then need to supplement it with things that are important to the client overall. So that could be things like BREEAM and WELL standards, so that we've effectively got some minimum criteria that we need to achieve, as well as achieving the vision. And then that's it. We've completed the research piece to some extent at this stage of the process anyway, and we can move on into design. And then we can take all of the information that we've learned about through research and look at the user journeys of those particular personas. So as I said, this persona here, apologies, I appreciate that the text is small on this, but effectively somebody's arriving on a bike and they need to find the parking space. So they're finding the empty bike space, they're looking for the changing rooms, they then want to get their coffee. You know, if we look at each persona in this level of detail and how they move through the building, we can really start to see where our focus needs to be on the technology. Is the technology at the front door, or actually does it need to be app-based so it's on their phone before they even arrive at site? You know, there's lots of questions that thinking about design in this way should really bring about. So this is not just about smart buildings, I guess. This is about moving design process on in engineering to another level, really, in my eyes. Once we've done all of that, we've got all of the information, we've got the user journeys, we understand what's important to the client. We need to put that information back to the client. And from a technical perspective, this is where the technology does get important again, because we might have different people now looking at the output of this information. It's not necessarily the facilities manager or a director responsible for the project. It might be a technical director that's actually just interested in how they're going to apply their systems and interact their systems with the building itself. So let's make sure that what we're proposing is really, really clear. So let's call it something. Let's give it a name. Let's give a solution a name and give it a really good description that people can understand. And then let's score these solutions against the original survey data. So, if the feedback for this particular idea isn't a low priority, let's make it just clear. And then when we come to actually deciding which of these solutions we want to integrate within a building, we know where we are. We know where we are from the end users because of the survey data. We know where we are from the facilities managers. We know where we are from the other stakeholders, the budget holders and so on. So let's provide as much information in as clear a way as we possibly can, is where I'm coming from. Because at that point, then you've got all of the information about the user experience that you need, and you can start bringing in information about other aspects of the building. So you can bring in the information about the building characteristics and perhaps about the local building market. Are these systems available that you really want today? Are there contractors locally that effectively can help you deploy these solutions? Do you have somebody that can look at programming that large database? I talked about the cloud platform effectively. So we can bring all of those solutions in together and create what we call is the opportunity matrix. And the opportunity matrix tries to summarize all of this information into one space. So effectively, you can make your decision just on one dashboard. So that might be about what the opportunities are. It might be how you're going to have to procure them and the cost. It could be about whether or not it fulfills the user experience that you originally wanted, and what the impact might be on sort of timelines for construction and so on. And ultimately, you could include your clients. You can see this was a Google review. You could include your clients' preferences. Do they want to give you the go-ahead on this? Is this actually achieving what they really want? And we can give that back to the client and say, there you go. Of all the 24 solutions that we came up with, there's 6 or 12 there that really tick the boxes on what it is that you're wanting to achieve. So a lot of focus about user experience, but I think it's really important, because without focus on the user experience, the technology is going to be useless, really. It will just sit there on the wall and not be used. So we have to make sure that it ticks the boxes in terms of that. So just moving on then now to how we enable the smart building. This, like I said, is the slightly more technical part, but I'm not going to go into too much detail. So I'm more than happy to have conversations after the meeting with individuals if they do want to talk about this in more detail. But effectively what we're talking about is, traditionally, we tend to design building services systems as silos. So we'll have a head-end PC. There'll be some controllers distributed around the building, and those controllers will be connected to pieces of equipment. So it could be a light fixture, it could be a temperature sensor, whatever it is, but they tend to operate in silos, and you might get some interaction with those individual silos. So some people in the past have put in systems that effectively can visualize that information on one screen, we'll call it. So effectively like an overall management system. But what they don't do is really talk to each other. And that's where we want to focus. We want to really think about this cross-system integration to make your building smart. Like I said, everything within here is automated. When you go across the systems, it becomes smart. So our suggestion is that we look at each of individual subsystems, and we carry on doing what we do with those subsystems. We're not trying to change the way that we design them wholesale. What we want to do is overlay what we call a gateway on top of each of these subsystems. And the gateway is there to translate the data from the proprietary languages that are used in each of these systems into a common language that then can be transmitted into the cloud-based platform. Because if all the data in the cloud-based platform is of the same standard, then immediately it can be used across those systems. So effectively, this might be one language, goes up through the gateway, suddenly becomes the language that we want to use. We can then interact with the platform and let the technology do the interaction with the individual system. So hopefully that makes sense. So effectively, you might have an app on your phone, and the app is actually controlling data in the cloud-based platform, which then gets transmitted back into the individual systems. you are not effectively making a direct change to one of these individual systems. There's some technology happening in between the two. And we believe that this is, you know, the right way forward because it's effectively vendor agnostic. You could go to any manufacturer for each of these subsystems, and we're converting them into a common platform, a common data structure. Hopefully that makes sense. This quite complicated, certainly up on the slightly up on the geek scale, to be honest. But effectively, what this is trying to show you is the individual systems. So it could be lighting, could be lifts, could be BMS and fire alarm. This is where the gateway would be. So each system is working in its own right. The gateway sits at the top, sends the information up to the cloud platform, which is all the purple area here. And that allows the apps effectively in the gray to talk to the cloud platform. So hopefully that makes sense. So it could be, you could have a system over this side. So it could be a room occupancy system that effectively is talking to our cloud platform. And that might actually then interact to say, well, this room was booked, but it's not been used. So the people that are there to try and clean down the room afterwards can see that the room's not been used and they don't need to go and clean the room anymore. There's no need. You could find that you can start to make savings. Or it could be that a room actually has been used ad hoc. Well, it could be that we've got sensors in the space to be able to tell us that. We might have CO2 sensors to say, hang on a minute, this meeting room in this location suddenly seen a spike in CO2. It's obviously being used for something. Perhaps somebody should just go and take a walk past it to see if it needs a clean down. So we can use that data in different ways. And by looking at the data in this way, so this is the single solution that I was talking about, we can then scale this no matter how big your estate is. So you could have one platform for your entire building estate, whether or not it's all in one location or across the UK. And all of your buildings then feed data into this one platform. That means you need to develop your app once, because once your app is developed for a particular platform, you're then effectively just filtering data to see what you want to see. So it might be that for me, working in Birmingham, I would only see the building that I'm interacting with in Birmingham, but it's exactly the same app that a colleague of mine might see working in London on a London building. So effectively, it's a very scalable solution, and the investment that you need to make on the platform here can be scaled up and increased in capacity as time goes on. So it's a really good solution for particularly if you've got large estates to manage. Just want to touch on this. This is naming convention, and this is the last slide about enabling a smart building. So this is something that we, I think we struggle with as designers and engineers sometimes, which is effectively coming up with a really clear way of defining what it is that we're designing and giving everything a name. This becomes really important because if you can't access the data that you've enabled in your building, then you're never going to be able to create apps in the future. We need to know that every single room is named consistently, that every single piece of, every single luminaire light fitting is named consistently, that everything, every temperature sensor has got a consistent name, so that when you're searching for information, when you're creating these apps and designing the apps, effectively you know what search strings to look for. It's almost like if you imagine going back in time trying to search your physical hard drives for a document that you know you've saved somewhere on your hard drive. 5 years ago, that was still quite difficult. Now, if you're using cloud technology, the search is far better, and a lot of that is about metadata and tagging of information. So we must make sure that we tag the equipment and tag the information in the right way so that we can get access to it in the future. And ourselves and Google and others are working with the Open Data Institute to try and make that as clear as possible. It's still early days, so you know the one solution isn't necessarily there yet, but we are moving forward, and there are some solutions like a naming convention called BRIC, which has certainly moved things on considerably. So that to me, hopefully is sort of explained about how we propose you enable your smart building. So effectively, you carry on designing what you do. We put a gateway on top of all of your systems, and the gateway talks up to the cloud. And then it's in the cloud where you do the interaction between the various systems so that one system can talk to another. It's also quite resilient as well, because effectively if you did lose your cloud solution, your lighting control will carry on working like it normally does. It's not reliant on that cloud connection. It's just there to effectively supplement the operation of that one system. I appreciate that the concept probably takes a little bit of getting used to. So perhaps if there's questions around it, I can come back to those slides later on. I just want to touch on how this might then affect the design stage and and how we need to interact with things at design. And it is important because we need to understand and we need to do the user experience design up front. This is where that work needs to be, right at the early stages of the project. We can then carry on developing the solutions, the technical solutions, like we normally would do during stages, Reaper stages 3 and 4. So sort of the design development and the technical design stages, and then send it out to tender. So that bit's not changed too much, but we must make sure we've got the information at the start. But what we also need to think about is the apps and the cloud platform. And at some point, you've got to introduce another work stream effectively to get that cloud-based technology up and running and get the ideas about the apps that you want at the point that you want your building to open programmed. So effectively that's the red bar. So there's now a few extra parallel paths, and one thing that's really critical is this data validation piece at the end. And if you can imagine, all of a sudden we've got 4 or 5 different building services systems with hundreds of sensors and hundreds of what are called endpoints. We need to know that they're programmed correctly. So that data validation is key, because if there's a piece of data that's not correct, trying to find it later is going to be like a needle in a haystack, really, and trying to find where these issues are. So you might then need to think about a smart building contractor whose prime focus is making sure that the data that's being inputted into the cloud-based system and onto the individual systems is validated to a huge level of accuracy. So that's a really important piece of work as well. Let's make sure that all the work that we do is accessible at the end of the job. Otherwise, without this validation, you might actually find that you can't do what you were expecting to do. And of course, we've got a new range of systems as well. So you might have some, as I said, some extra sensors. They might be called IoT sensors. We've got to test them all. We've made to make sure that the connectivity is correct. You might actually have a separate sensor package. So we might have air quality sensors now and people counting sensors that you wouldn't typically have seen in the past on a building. So we need to think about how this is going to be delivered. Is it going to be delivered directly to the main contractor? Personally, I think that's quite a good solution to look at, to make sure that you've got as much accessibility to these people as you can. But equally, in time, I've got no doubt it would typically be delivered by the traditional MEP contractor as part of their general supply of technology like access control systems and metering and so on. So, but it's important to consider what it is that's going to be delivered and how it's going to be delivered, because it will change contracts to a point. Definitely need to be thought about. Okay, and then the last section, which I think we're doing okay for time, so not too bad. Last session is about visualizing smart building data, and I said this was equally important because I want to give a real example, I think, of why it's important. So this is an Arup example. I couldn't help it, unfortunately, but I remembered this from when it went live back in 2013. And this was a colleague in Arup that effectively took all the scheduled flight information and decided to produce it graphically. And it created these amazing images, really quite beautiful images of flight paths around the world. And you can see obviously the various concentrations, and you can just make out there, that's the UK. That is a really powerful message of all of the flight paths around the world. And why I think it's quite important is that information existed way before Michael put the images together, but it existed in a scheduled format, a format that most people, most people in the right mind, to be honest, would never want to really interact with. It's scheduled data that somebody can use, but it's not visual, so people can't necessarily access it that would be interested in it. This guy decided to make it visual, and all of a sudden it made the BBC News. Now that shows how visualizing data is really, really powerful and really important in what we do. So we're looking at that in a number of different ways, and we're spending quite a lot of time at the moment focusing on that and how we can visualize information in various different ways. So this image on the right from the Sibsy magazine recently was about reality capture. That's effectively my own office. Reality capture and how we can effectively use that to pass on information in a much better way. And just a couple of examples that I want to share with you, because I think it helps reinforce the message. Public consultations at the moment, bit of a challenge. Obviously, you can't have mass gatherings, you can't really invite people into these sort of environments. So there's a system here that is using data in a different way. This is effectively an online portal where public can log in. They can go and decide then what they want to have a look at. So this information on the left might be some static information, so static data that they can go and interact with and they can read. the person sitting down here is actually, got a chat function. So you can click on the chat button and you can chat online with this person. So that's another way of interacting with data effectively. There might be some graphics and videos that you can look at the back, and there's the 3D goggles there that you can put on, effectively change the image. So this is about trying to get information, trying to get data out into a public environment in a really straightforward way that people can interact with. Again, in a situation at the moment that we're in where you can't actually meet very easily in real time. So really good demonstration of data. And then just another explanation of data and why it's important. Our pedestrian modeling software that we use, called Mass Motion, it's been around for a number of years, and it's often used in transit type environments, large infrastructure environments. We've adapted it now so that you can effectively see straight away when two people are too close to each other, within 2 meters of each other. And there's nothing better than seeing that visually, so we can actually plan offices, plan the layout of offices based on simulations of people movement, but visual simulations, so you can see where those hotspots are that you've got to try and address in a very careful way. So another good way of data. And then reality capture, bringing it to an end. There's various different ways that you can capture reality in your building. We could start with a basic idea of having some data from Excel, using your fire plans and using a 3D panoramic camera. And you could bring all of that together and effectively capture data in a different way than was there before. So fairly basic, but still quite useful. So bringing information and real images and replacing your fire plans, let's say, with something a bit more interactive. Or you could take that to the next level and you could use what we call, what is known as a Matterport camera. So this is actually a physical company called Matterport that produced this camera. It's a great piece of software. And we could take data out of another system that you might have. So it might be, like I said, it could be people counting or access control. So you might want to know who's entered the building. And you could use a cloud-based technology to bring that information together. Or the hardest one, if you like, and this is easy to hard, is where you've got a lot of database information in a facilities management package like Maximo, and you've got your BIM data, and you might want to bring those together and visualize it in augmented reality. And we're just at the point of looking at this in a lot more detail. We've actually now got data flowing from a facilities management platform onto a reality capture platform and visualizing it in a different way. So this is definitely possible, but this is where it's really starting to emerge at the moment, of bringing that information together. And then the final slide with a bit of a video. Hopefully it will work. That looks promising. So this is Stansted Airport. It's a great case study, brings it all together in my mind. So Stansted were experiencing overheating in their baggage handling hall. We installed some sensors. The sensors were reporting their temperature onto an online platform, but the engineers couldn't understand where they were, so they didn't really have a concept of where they were physically. So what effectively we've done is we've overlaid that sensor data onto a Matterport scan of the baggage handling hall, and now you can walk around virtually and see the real-time data pop up in the various locations where these sensors are. So this is a far clearer demonstration of bringing and overlaying real-time data into a reality capture like Matterport, so that everybody that works and interfaces with the baggage handling system can look at this and understand it straight away. You don't need any particular degrees to be able to understand that that was a temperature sensor. So hopefully that just wraps everything up, and hopefully that's of interest to people. Open to questions. Feel free to chip in.
Thanks ever so much, Richard. That's fantastic. Really, really interesting presentation. We have had a few questions in, so if I jump into those, and apologies, we probably won't be able to get through all of them. One from Erland Rendell. So he's asking, with significantly enhanced awareness of building and office health, particularly individual health, how has the last 4 months impacted user experience requirements? So this is looking to the medium-term future.
So I'll just try and play that back if that's okay, just to make sure that I've got the understanding okay. So I think this might be about looking at occupation of building, how many people are in buildings, and actually the environment within a building. Well, actually, if we got those sort of smart technologies now, that would definitely help, because we could look at measuring more information, taking more information from that building, whether that's CO2 levels. You could look at VOC levels in a building, so look at the number of particulates and so on that are in that building. So that might give a much more informed decision about when it's appropriate for people to come back into the workplace and how many people might be appropriate in a particular workspace. I've actually got quite a good example of where somebody's used that type of environment. It's not about the COVID experience, but effectively they had an office environment where they found that one corner of the office wasn't really being used very well, and they set up some additional sensors to try and look at that. And what they actually found was that the space was being used really well in the afternoon, but in the morning nobody was there. Nobody went to that space early in the morning. They put the sensors in, and actually what they found is there was a problem with glare. So early morning sun coming through the windows was creating an environment that just didn't really work for people. So they repurposed that corner of the office. So they moved some of the static, you know, it could have been the library, I'm not entirely sure, but they moved the sort of another area to that space and moved the desking out of the way of the glare. I think, you know, I think that type of interaction with data really allows you to understand how your building's going to work in a lot more detail. So medium future, tricky for me at the moment. I'm sort of, it's a bit of a strange situation really, because a lot of people are looking at, you know, working from home, and they were looking at working from home before COVID as well. And you were looking at diversity and utilization of spaces. I think we're in a strange situation with spaces at the moment, because effectively suddenly we've got to increase the amount of space that a single person takes up. And so where before you might have been looking to try and shrink the space a little bit for higher diversities, you might not be able to take advantage of that. So you might not actually be able to reduce your office sizes quite in the way that you were thinking of doing it. Hopefully that answered part of the question. You know, VOC, CO2 measuring definitely will help in terms of considering health impacts on interacting with buildings.
There's a comment from Geralt Hughes, which was regarding user experience, which is something that I think quite a lot of us could relate to, and is key in your talk. That he was the sentiments of keeping systems simple was key.
Absolutely.
And that I think he was visiting site, and there was a lift commissioning program going on, and I think there was a linking of speed gates to calling lifts.
Yes.
And I think we've probably all experienced this, where users struggle with that. The lifts are automatically called. So there is this piece around user experience and making sure that people appreciate how to use the experience and utilize the experience is a key consideration.
Definitely, you know, that narrative that I talked about considering the user journeys and really thinking about the different people. So if you're used to working there, okay, the first time you turn up to work and you swipe your card on the access barrier, the barrier opens and it tells you which lift to go to. It might be a bit of a surprise on the first day. Within a week, you've probably got used to it. But if you're a visitor, that same interface, that same interaction will happen every single time that visitor arrives at that building. So what's the narrative? How can we actually look at a different journey perhaps for the visitor than for a normal employee? Perhaps it's actually better forgetting about the interaction with the visitor and just letting them go and call the floor that they want to travel to, because that's more natural to them.
Mm-hmm. So we've got another question from, apologies if I pronounced the name wrongly, Sylvan Thorzo. So they're asking if you think that these technologies could be retrofitted. So can you enable smart buildings into an existing asset in a cost-effective way?
Absolutely. So that's one of the benefits that we think in looking at smart buildings and the way that we're looking at them. We're not trying to replace the technology that's in buildings or being developed necessarily at the moment for buildings. We're supplementing it. We're putting these pieces of hardware that we call gateways to translate the data from your existing system into a common format that then can be understood by all the other systems and the apps. So on an existing building, it's definitely a good way to explore, have a look at the systems that you've got, do a bit of research to see what languages, what data those systems use, and then have a look at potentially putting the gateways on them so that the language is converted into a common language that you can then interact with, and then that you can effectively put the smartness into the common language, and the gateway deals with the translation. So definitely a good solution for existing buildings.
Fantastic. And then we had one more, and perhaps we'll have this as the last question. Appreciate time. So do you have your own occupier app to deliver occupier experience in your assets? So they recognise the market is becoming quite competitive, and I think we touched on this just before the presentation today. So there's a question on that, if you have your own occupier experience app at the moment.
So that's something that Arup are looking at doing. At the moment, we're enabling the smart buildings. Like I was saying, we're trying to effectively create the opportunity for people to put the apps together. We're also quite aware that we're not operating buildings as a company. So Arup as a company is not, sort of operating buildings for a large number of people. And we know that those companies, such as Savills and Jones Lang LaSalle, those type of companies are creating apps, and they can apply those apps across the estates that they're managing. However, we do think there's going to be some benefit in providing a base level of technology and a base app potentially in the future to really help people sort of get using the technology more quickly. So it is certainly something that we're looking at doing as well.
Awesome.
We don't have one today, but hopefully soon.
If I may, I'm going to try and squeeze in one more question from Keely War. And so this is around sensors and incorporating sensors into buildings to try and capture some of this data. There's quite an investment in that. So is there a level of retrofit that you can do? Can you use infrastructure that's already in place, swipe cards, etc., to capture data?
Yes, you can. Obviously, you've got to be a bit careful about GDPR if you're capturing information, particularly from access control systems. But most modern systems do have the ability to export data from those systems. So you could definitely look at that if you wanted to understand about use. And if you anonymize the data in some way, then I would imagine that you'd be able to start to use that information. You could also look at hiring systems and hiring sensors. You don't necessarily need to install these permanently. So the Stansted example that we gave, I think the sensors were installed for a month, and that gave them the information that they needed to be able to make some decisions. So you could hire sensors that are effectively operated over 4G, and that then effectively sends the data off into the web that you can then analyze to your heart content later.
Fantastic. That's brilliant. Well, thanks again. Thank you, Richard, for the talk this afternoon from Arup, and thanks ever so much for introducing a beginner's guide to smart buildings. It's hugely appreciated and massively informative talk. A great intro to it. Quite an exciting topic, and appreciate this focus on the user experience and making this key and the center to that. So thanks ever so much, and thanks everyone for joining us this afternoon. Thank you for the questions, and then just a quick reminder that we've got some more of our webinars coming up. So please have a look on the BCO events page for our upcoming webinar program. And I think that's it. Thanks ever so much, everyone, for joining. Thank you, Richard. Appreciate your time, and we'll hopefully catch up soon in the virtual world and the physical world as well. So thanks ever so much, and bye for now.
Thanks, everyone. Bye-bye.
Thank you.